Welcome back for part 2 on graphs of proportional relationships. We are still playing with our tortoise and our hare. Of course, a hare is a fancy English name for a rabbit. Same information is given to us, and now they say determine the distance the rabbit moves is proportional to the time by graphing the relationship on the coordinate plane. So now we have a different set of data. We have the data for the rabbit instead of for the tortoise, and you are going to pause your recording, graph it on the rabbit's pace on the coordinate plane, and after you graph his information, filling out this as you go, then you're going to, of course, check your answers and see whether or not you believe it is going to be proportional as well. Pause the recording, work on this. Did you get it done? Let's take a look at the first part. Put it in our ordered pairs. That's going to be 0, 0. Then I'm going to have 1, 8. Then I'm going to have 2, 8. And finally, I'm going to have 3, 15. Check that answer. Everything checks. Now, if you remember the story of the tortoise and the hare, you remember that the hare, the rabbit, took a nap. He was so cocky and overconfident in his abilities, he decided he was going to take a nap. And the rabbit, the tortoise came by, he turned the rabbit stick around so that he lost track of what direction he was going, and he ended up losing the race. And that you see going on right here. On our chart, you can see that Mr. Rabbit ran really hard for the first minute or hour. What was our time? Yep, for the first minute. Then he laid down and slept for a minute. That's a very short nap. And then he took off and ran really hard for another minute. But that is not a straight line, is it? It goes through the origin, but it is not a straight line. As a result, the relationship between the time and distance is not proportional because a graph is not a straight line. Check your answers. Is there another way you could determine if the relationship is proportional or non-proportional? As a matter of fact, there is. We've talked about a couple where we could simplify them down to where they all had the common denominator, or simplify them down to where they were all a unit ratio, which would be a common denominator of 1. What part of the scenario makes a relationship non-proportional? Well, that would be when your numerators do not match when you have a common denominator doing it that way. The table shows the number of calories an athlete burns per minute of exercise. Graph the relationship and determine whether the number of calories burned is proportional to the number of minutes. Pause the recording and do that, and then we're going to come back and check what you did. I made it a little bit smaller for you, so if you're not working off a device, you can see all parts of the question. When I made my graph, it ended up looking like that. It started off beautiful for a proportion. The first 2 points gave me a straight line that went through the origin, but then we made that hard right turn there so that the entire data set does not produce a straight line. Since it does not produce a straight line, let's check our answer. It says it's wrong, but I know it's right. My answer, check answer, show answer. Yeah, that's the answer they gave. That's my answer. It's the same exact thing. So my answer is good. And from there, we're going to say the relationship is what? It is not proportional because the point does not form a straight line that passes through the origin. Requires both things. Check our answer, and that one they gave us credit for all parts of it. When a proportional relationship is graphed, you can determine the constant of proportionality using the coordinates of any point on the line other than the origin, because the origin is 0 divided by 0, 0. But if you divide any other point, y divided by x, it's going to take and give you what your constant of proportionality is. For example, in this graph, we have it set to where you have 5 divided by 2, or 15 divided by 3, 20 divided by 4, and so on. Now, if we were to select a point like they said, you can see that 10 divided by 2 becomes 5 over 1. If we were to do the 15 over 3, it becomes 5 over 1 as well, simplified. And if we do the 20 over 4, it too becomes 5 over 1. So what's your constant of proportionality going to be? It's going to be 5, of course. What do you notice about the constant proportionality and the coordinates for points 210 and 315? Well, I think that what I would notice is that if I was to simplify those ratios, it would come back down to that 5. If I was to take the 10 divided by 2, I get 5. If I take the 15 divided by 3, I get 5 again. In a 100-meter race, assuming the runner's rate is constant, the distance run is going to be proportional to the time spent running. One runner's data is shown on the graph. Find the constant of proportionality. Describe what it means. Think about this. How should you begin solving the problem? Maybe find your x and y values, set it up to where you have y divided by x, just like we showed you in that previous note slide. Let's see what happens here. So, on the graph, we start off with, you got 0.00. So after 0 seconds, the runner traveled 0 meters. After 5 seconds, he traveled 31 meters. After 10 seconds, he traveled 62 meters. And after 15 seconds, he traveled 93 meters. And you can see here, they've given you an opportunity to lay those out in y over x fashion. Pause your recording, get that done, check your answers. So what were my relationships? Well, the 31 went over the 5. Next I have 62 and 10, so the 10 goes under the 62 here. And finally we had 15 and 93, so 93 is going to go on the top, 15 is going to go on the bottom. Check my answers. Excellent, everything is good. Scrolling down, write the ratios with a denominator of 1 to find the constant of proportionality. Here they took and divided each one by the denominator. To do that, they divided by 5, got 6.2 over 1. They divided by 10, got 6.2 over 1. And they divided by 15, got 6.2 over 1. The same exact ratio. So you have that constant ratio 6.2 over 1, and the constant of proportionality is that 6.2. Now you get to pause the recording one more time and answer this question. Because the constant proportionality is 6.2, this means that the runner moves at a constant rate of 6.2 what? Is it seconds per meter or meters per second? The answer is meters per second. Check your answers. Very good. Based on the constant of proportionality, 6.2, how far will the runner travel after 20 seconds? Pause the recording. Solve it. Explain your reasoning. Now when I solve this problem, I'm going to set it up as a ratio 6.2 meters in 1 second. From here, meters per second. Yep. I'm going to take and multiply by, let me see, what was that goal? What did we want to know? 20 seconds. So multiply the top and bottom by 20. And when I do that, of course, I'll have 20 seconds on the bottom. On the top, we're going to take and get, I believe the answer is going to be 62 meters when you multiply that out, because you get, nope, it's not either. It's not going to be 62 meters. It's going to be 120 meters. And here's how we're going to prove it. 6.2 times 20 seconds. 0 times 2 is 0. 0 times 6 is 0. 2 times 2 is 4. Oops, I got the wrong answer. 2 times 6 is going to be 12. And we're going to add those up. 0, 4, 2, 1. Bounce, bounce. Correct answer should actually have been 124 meters in 20 seconds. So from there, we could, nope, nothing to put in. That's it. The black mamba, I've seen them talk about this critter before. Obviously the author likes this snake, the fastest snake in the world. Assuming the snake travels at a constant rate, the distance it travels is proportional to the time spent traveling. The graph shows the distance the snake travels over a period. Find the constant of proportionality and describe what it means. Well, you got 0.00, 0.115, 0.230, 0.345, and 0.460. Notice how those are written: parentheses, number, comma, space, number, close parentheses. You pause the recording, find your constant of proportionality, and describe what that constant of proportionality means. This one is actually pretty easy. We can pick any point we want other than 0.00. So the smart choice is going to be to take and pick, let me get my marker going here, that point right there, the 15 to 1. When you do your y over x, your y value is 15, your x is 1, that means your constant of proportionality is 15. If you had picked another one, say maybe you wanted to use 0.460, that means your y over x would have been 60 divided by 4, which is still divide numerator by the denominator by the denominator. And what do you get? Oh, not a triangle. We don't want that triangle in there. You end up getting 15 over 1 with that same constant of proportionality being 15. So with that information, we can go back to our problem. Constant of proportionality is going to be 15. Check that answer. It checks good. And we can say, what does it mean that the snake moves at a constant rate of 15? 15 what? It was feet per second. Check your answer. Answer checks perfectly. Let's move on to the next slide. Now we're going to use Web Sketchpad to explore this problem. What are special points on a graph of a proportional relationship, and what do they actually represent? So let's take and move on. Push the car. Alright, to see the car move for 5 seconds. So here we go. Wait, hold on. What does it have here? That's where we put the answer. So push the car. Oh, well, isn't that just as cute as it can be? And it's moving all kinds of feet. And how far is it going to go in 5 seconds? Boom, it went 20 feet in 5 seconds. If you were just really excited by that, you could reset it and push the car again, but I kind of get bored with that. So how far did the car go in 5 seconds? It went 20 feet. Check our answer. And that checked good. Hit our next slide. Find the data. If the data was graphed on the coordinate plane, the x-axis and the y-axis should end up being labeled, where your x-axis is going to be your, let me see here. You got 20 feet. The x-axis is going to be your time, I believe. The y-axis is going to be your distance. Let me think that out for just a second. In the end, I don't think it really matters, but let's see what they said I was right. They said I was right. From here, we're going to move on to the next slide. Now, which point of the graph represents where the car began? Well, the car began at, let's look at our graph here, all the way down there at point A. So the car is going to begin at point A, which is at time 0, distance 0. All right, move on to the next. What point of the graph represents where the car ended? Well, that was at 5 seconds time. At 5 seconds time, he traveled 20 feet. So that's going to end up being point F. Plug in point F here. Check your answer. All is good in the world. Now, what do you notice about the constant of proportionality? The unit rate and the coordinates of point B. Well, at 1 minute's time, let's zoom in here a little bit. 1 minute time we have right here. That lines up to point B, which is going to be 4. And the constant of proportionality is 4. It takes place at 0.14, and you would write that as a ratio as being 4 over 1. Use the point labeled, drag to change the rate. Where is point B located now? How does it compare to the unit rate and the constant of proportionality? Well, isn't this one cute? If we were to take the orange dot and grab it to where, say, we have a 7 feet per second, now point B, the graph's becoming much steeper, and point B is at 1.7. If we would come back to 1 foot per second, now it's less steep, so point B is at 0.11. 3 feet per second, point B is at 0.13. So however many feet per second you're traveling, that unit is going to be your constant of proportionality. It's also going to be the y value where x is equal to 1. What are special points on a graph of proportional relationships, and what do they represent? Take and pause the recording, see if you can get the answer. I got a pretty good idea, but we never really did spell that out for you. So put in what you think the answer is, and then we're going to spell it out. 0.00 is a special point. It represents the origin, and your other special point is 0.1 R, where R represents what your unit rate is. All there is to it. 2 special points, your origin, and whatever the y value is, where your x value is equal to 1. That is going to be it for part 2 of graphs of proportional relationships. Come back for part 3, which we hope to make the last part of this series for chapter 1, section 4.